Welcome to Network the lecture series. Today lecture we are going to see about basics concepts regarding DC circuits. So, electrical circuit theory. So, what is the important of the network theory? That is, the electric circuit theory and electromagnetic theory are the two fundamental theories upon which all the branches of electrical engineering are built. In electrical engineering, we are often interested in communicating or transferring energy from one point to another. To do this requires an interconnection of an electrical devices. So, and also this electrical circuit is very important in a power system, electrical machines, control, electronics, and communication instrumentation are the based on the electric circuit theory. Therefore, the basic electric circuit theory courses is the most important course for an electrical engineering students and always an excellent starting point for a beginning students in an engineering education. Circuit theory is also valuable to the students specializing in other branches like physics, physical science, and also in this the electrical engineering we are often interested in communicating or transferring energy from one point to another. So for this, we are requiring the electrical connections, interconnections between this circuit. The interconnection is referred to as an electric circuit, and each component of this circuit is known as an element. So each component in a circuit, we can call it as an element. So electrical circuit is an interconnection of electrical elements. So what is the electrical circuit? It means that interconnection of all electrical elements, that is we can call it as an electrical circuit. So in this diagram shows that the battery, lamp, and current flowing through the circuit, these are the entirely it is called as an electrical network. Shows the see this showing the simple electrical circuit in a diagram which is showing a simple electrical circuit. It consists of the three basic components like a battery, lamp, and connected wire. Such a simple circuit can exist by itself with the help of the battery. Okay, so before we are going to discuss about the electrical circuit, first we need to know the fundamental of the system units. So systems of units, we have different types of units. So before we are going to study about the electrical network, you need to know the what is the important of the unit, what is the SI units. In electrical engineers, we deal with measurable quantities or measurement. However, must be communicated in standard language that virtually all professionals can understand, irrespective of the country where the measurement is conducted. Such an international measurement language is an international system of units that is called SI units. That is called an SI units, adopted by the General Conference on Weights and Measures in the year 1916. In this system, there are six principal units from which the units of all other physical quantities can be derived. We have six physical quantities, so six principal units. From that, we can derive all other systems. So the physical quantities are length, the basic unit is meter, that is mentioned in a symbol small m. Next, mass, the basic unit is kilogram, that is symbol is kg. And time, the basic unit is second, that is denoted in S. Next, electrical current, the basic unit is amperes and the symbol is capital A. Next, thermodynamic temperature, that is denoted in a basic unit of Kelvin, the symbol is capital K. Next, luminance intensity, the basic unit is cantilla, that is different denoted by the symbol small c and small d. So these are all the basic units that is derived from the SI units. And also in the SI unit, we need to understand the prefix of the SI units. So these are some prefix before going to enter into the subject. We need to know this prefix of an SI unit. So it is a multiplier and prefix and the symbol. So multiplier 10 power 18, that is exa, it is the symbol is capital E, and 10 power 15 is denoted as peta, the symbol is capital P, and 10 power 12, that is tera, that is denoted by T, and 10 power 9 giga, that is symbol is capital G. Mostly we know this gigabyte. So 10 power 9, that is G. Then 10 power 6 denotes mega, that is denoted by the capital M, and 10 power 3, that is kilo, it is denoted by small k, and 10 power 2 hector, that is denoted by H, and 10 power giga, that is data, and 10 power minus 1 deci, denoted by D, and 10 power minus 12 centi, denoted by small letter C, 10 power minus 3. So mostly 10 power minus 3, minus 6, minus 12, we are mostly familiar in this in engineering. So 10 power minus 3, that is milli, denoted in small m. 10 power minus 6, that is micro, denoted by in a unit micro. So 10 power 9, that is nano, that is in small m. 10 power 12 pico, that is in small p. Then 10 power minus 15 femto, that is in m small f. 10 power 18 auto, that is small. So you can see mostly the 10 power giga, that is mostly we are using mega, kilo, mega and kilo, and in a negative we are mostly using milli and micro and pico. So mostly these are all the prefix most probably we are using in this electrical circuits. So these are the basics of the SI units. Why the SI units are comes, what is the role of the SI unit. So the important of SI unit is we need to communicate all over the world in a same language. So that's why the SI units are introduced. Okay. So next we are going to see about basics concept of the current and charge in a DC circuit. The concept of electric charge is the underlying principle for explaining all electrical phenomena. Almost the most basic quantity in an electrical circuit is an electric charge. Most is an electric charge. We all experience the effect of electric charge when we try to remove our full sweater, removing the sweater, and have it sticks to our body, or walk across the carpet and receive a shock. So that is a charge. So what is a charge? A charge is an electrical property of an atomic particles of which matters consist, measured in a unit of coulomb. We know from the elementary physics that all the matters is made up of fundamental building blocks known as atom, and that each atoms consist of electrons, protons and neutrons. We also know that the charge E on an electron is negative and equal in magnitude to 1.602 in 10 power minus 19 coulombs, while a proton carries a positive charge of the same magnitude as the electrons. The presence of equal number of protons and electrons leaves about electric charge. The following points should be noted about electric charges are: the coulomb is the large unit of a charges. In 1 coulomb of a charge, there are 1 divided by 1.602 into 10 power minus 19, that is equal to 6.24 into 10 power 18 electrons. And also, according to the experimental observation, the only charges that occurs in natures are integral multiples of electron charges, E equal to 1 minus minus 1.6.0 10 power minus 19 coulombs. One more important law, that is law of conservation. The law of conservation of charge states that charge can neither be created nor destroyed, only it can be transferred. We can transfer the charge from one form to another form, but we cannot destroy the charge. We now consider the flow of electric charge. A unique feature of electric charge or electricity is the fact that it is mobile, that is, it can be transferred from one place to another, where it can be converted to another form of energy. We can transfer and we can convert in an electrical charge. So this diagram shows, so it's a battery, it's connected in a battery, it's connected in a battery. The electrons are flowing from negative, the currents are flowing inside. The electric current due to flow of electric charge in a conductor. Here the electric charge is flowing. Electric current is the time rate of change of charge measured in amps. So what is the current? The electric current is the time rate of change of charge measured in an ampere. Measured in an ampere. Oh, so the mathematical relationship between current and the charge and time is I equal to dq by dt, where current is measured in ampere and 1 ampere, that is equal to 1 coulombs per second. The 1 ampere, that is equal to 1 coulombs per second. Next, the charge transfer between time t0 and t is obtained by integrating both sides in an q equal to integral t0 to t I into dt. I into dt. The way such that the current need not be constant valued function, as many of the example and problems, the several types of current are introduced. That is, the charge can vary with the time in several ways that may be represented by different kind of mathematical functions. If the current does not change with time but remains constant, we can call it as a direct current. The current will not change with respect to time, then we can call it this current as a DC current. An alternating current, a time varying current, is represented by a symbol I. Common form of time varying current is a sinusoidal current or alternating current. An alternating current is a current that varies sinusoidally with respect to time. This is a current varying sinusoidally, right? Such a current is useful in your household to run the air conditioner, refrigerator, washing machine, and other electrical appliances. Then figure shows the conventional current flow is shows that direct current and alternating current, these are the two most common type of current we will study it. Once we define the current as the movement of charge, the expert current to have an associated direction of flow. As mentioned early, the direction of the current flow is conventional, taken as a direction of positive charge movement. Based on this convention, a current of 5 amps may be represented positively or negatively based on the circuit operation. So next we are going to see about Ohm's law. So basics of Ohm's law also we are going to discuss it in this. So what is Ohm's law? Material is generally have an so what is Ohm's law? The material is a general have an characteristics behavior of resisting the flow of electric charge. The physical property or ability to restrict the current is known as the resistance, as it is represented by the symbol R. As it is represented by the symbol R. The resistance of any material with uniform cross section area A depends on the A and its length L, that is denoted by R equal to rho L by A. So this diagram shows this is a material, this is a cross section area A, and this is the material with the resistivity rho L, and this is the length of the material L. So where rho is known as the resistivity of the material in the ohm meter, the uniform cross section area or A depends on the A and L, its length. So Ohm's law states that voltage V across a resistor is directly proportional to the current I flowing through the resistance. So V directly proportional to I. The Ohm defines the constant of proportionality for a resistor to be a resistance R. The resistance is a material property which can changes if the internal or external condition of the elements are altered. Example, if there are changes in the temperature, thus V equal to I into R. The resistor R offers an element denoted its ability to resist the flow of electric current. It is measured in ohm. The resistance is an element that is ability to oppose the flow of electric current, that is oppose or resist. So the figure shows the short circuit is a circuit element. The short circuit is a circuit element resist the approaching zero. So short circuit, in this the resistance approaching is zero. If the circuit is short circuited, here the resistance is approaching towards the zero and the voltage is also approaching to zero, and we can obtain the maximum current. So V equal to zero and R equal to zero. So in a short circuit condition, R equal to zero and V equal to zero, I is the maximum condition. If an open circuit is a circuit element with resistance approaching infinity, if in the network having the open circuit condition, here the current in an open circuit, the current I equal to zero, and we have some potential difference between these two terminal and resistance approaching to infinite. So it is clearly we can say that in a short circuit condition the resistance is zero. In an open circuit condition the resistance approaches to infinity. There are some resistance with different types of resistance. This is a fixed resistance, mostly we are using in the electronics labs. So these are the fixed resistance, and this is the variable resistance, symbols of a variable resistance. So this variable symbol of a variable resistance denote, we have an variable arrow mark here, which denotes there is having a variable value. It's a variable value. Next, a resistance that obeys Ohm's law is known as a linear resistance. It has a constant resistance and thus its current voltage characteristics illustrated. So if the resistance always obeys the linear Ohm's law, that means linear. If we are changing the current irrespective linearly, the voltage will getting varied. So that is the resistance that obeys Ohm's law is known as a linear resistance. That is the resistance mostly it will in a linear device. Resistance is mostly a linear device only. A usual quantity in a circuit analysis is reciprocal of resistance or known as conductance and denoted by Xg. So till now we discussed about the resistance. What is the resistance? Then the inverse of resistance we can call it as a conductance. So inverse of resistance, what is the conductance? It is a maximum. It is the opposite to the resistance. So resistance will oppose the flow of electrons. The conductance is allow the flow of a electron. So the usual quantity in a circuit is a reciprocal of resistance or known as conductance and denoted by G. So G equal to 1 by R, that is equal to I by V. The conductance is a measure of how well an element will conduct electric current. That means how the resistance will denote how well the element restrict the current. The conductance is helps to how well the conductor will helps to conduct the current. The unit of conductance is a ohm. Ohm spelled backward. That is, you can spell in a ohm in a reverse. That is called a mho. or reciprocal of ohm, the symbol inverter ohm. Although the engineers often use the ohms or Siemens S, the SI unit of a conductance. So 1S that is equal to 1 ohm that is equal to 1 ampere per V. So conductance is a reciprocal of inductance. How will the circuit helps to deliver the maximum current? That is called conductance. So conductance is an ability of an element to conduct electric current. It measured in ohms or Siemens S. The power dispatched by a resistors can be expressed in terms of R, that is P equal to voltage into current, or otherwise I squared, or otherwise it is represented by V squared by R. With respect to conductance, so P equal to V into I, that is V squared into G, that is equal to I squared divided by G. So finally, the points to be remembered for an Ohm's law: the power dissipated in the resistance is a nonlinear function of either current or an voltage. Since R and G, resistance and conductance, are positive quantities, the power dissipated in a resistance is always positive. Thus, a resistance always absorbs power from the circuit. This confirms the idea that the resistor is positive element incapable of gathering the energy. So thank you. For next